In this video, we're going to try to go through how you're going to name ionic compounds. So when you're given an ionic compound formula, it's in its simplest terms. And so this means that I've got one magnesium ion and one sulfide ion. This means I have one magnesium ion, two bromide ions, and this is one magnesium ion, two nitrate ions. Magnesium ion, if we consult our data booklet, you can see can only have a positive or two positive charge. So this is an Mg2 positive, and the sulfide ion can be a 2 negative. So this is a fairly straightforward one to name. It's a magnesium ion with a sulfide ion. So it's magnesium sulfide. Pretty straightforward. This is a magnesium ion with two bromide ions. So this is magnesium bromide. You don't write down the number of bromides because as long as I know it's magnesiums that have a 2 positive, magnesium ions and bromide ions, it has to be a 1:2 ratio. This is a magnesium ion again, and nitrate ions. The nitrate ions are polyatomic, so you need to look into the polyatomic table that's on your periodic table. It's kind of in the middle over here, and nitrate is listed here. So this is going to be magnesium nitrate. So these are sort of the basic ones because magnesium can only have one possible charge. That charge is 2 positive. There are a bunch of chemicals, though, that have more than one possible charge, and these are called multivalent cations. So they can have more than one possible charge, and you need to know what that charge is in order to name it correctly. So palladium here, if we look at palladium, can have a 2 positive or a 3 positive charge. So it can be a palladium 2 ion or a palladium 3 ion, depending on what the charge is. So this is a palladium and a sulfide. Sulfide has a 2 negative, and palladium I only have one of. So if I only have one of these, it has to have the same charge but positive. So this is a palladium. And if we go back to the periodic table, you'll see the palladium that has the 2 positive is palladium 2 in Roman numerals in a bracket. Sulfide. This has got 3 sulfate ions. Oh, and sulfate has a 2 negative charge, sorry. So this has got 3 negative 2s, so it's got a total of 6 negative. The palladiums, I have 2 of them that need to come out to 6 positive. So these must have a 3 positive charge in order for these two net amounts of charge to be equal and cancel each other out. So this is a palladium 3 ion with sulfate. So this is palladium 3 sulfate. And here I've got palladium. I only have one of them. And I've got 3 fluoride ions. So I know it's going to be palladium fluoride, but is it palladium 2 or palladium 3? Well, if this has got 3 negatives, this has to come out to 3 positive, and I only have one of them. So it's going to be a positive charge. So this must be palladium 3 fluoride. And this bracket is indicating the charge in a multivalent ion. You'll notice the magnesium didn't need that because magnesium ion can only be positive 2. So if we showed up, probably the hardest ones I can ask you would be something like this. NiS, or perhaps VSO4 2. These are really much more difficult. Now sulfide can only have a 2 negative charge. And I only have 1 nickel, so it has to have a same net positive charge. So this is a nickel 2 sulfide ionic compound. But over here I have 1 vanadium. Vanadium can have a charge of So vanadium is listed here, and it can be +5 or +4. Well, sulfate has a 2 negative. So if I have 2 sulfates, there's a total of 4 negatives. So this has to come out to 4 positive. So this is vanadium 4 sulfate. And I think the one that's hardest to keep track of are the ones that are both even. So if you have manganese, manganese can either be 2 positive or 4 positive. And so if I have MnSO4, this will be 1 sulfate has a 2 negative, then the manganese has to have a 2 positive because there's only one of them. So this would be manganese 2 sulfate. And if I wanted manganese 4 sulfate, it's going to be this. And so you could get confused if you weren't aware of how you're going to get it. I've got a sulfate that has a 2, another sulfate that has a 2 negative, and I only have 1 manganese. So if this is 4 negative, this must be 4 positive. This must have a 4 positive charge. It's manganese 4 sulfate. You may need to take a look at this video more than once to make sense out of it, but if you follow the same pattern that I've worked on, you should come up with a proper name of an ionic compound pretty much every time.